Okay, hi everyone. Oh, it started raining. So I'm Alexander from Remote Aero. You might recognize me from last year, where I did a longer talk on our project with the Swedish Sea Rescue and how we provide early situational awareness for them. If you missed that, I'm going to do a quick debrief and then talk about some stuff that we're working on right now. So, Remote Aero's initial use case was with Sea Rescue to provide early situational awareness. So essentially give the people in the control center as well as the operators on board more information to take better decisions. So essentially that they know what they're facing and they can optimize their resource use efficiently. So the Swedish Sea Rescue has a very ambitious project now, putting these launcher fixed-wing systems all across the Swedish coastlines and in the big bodies of water. Currently there's just one in Gothenburg, but slowly getting there. We've also seen other potential use cases for this. We've been in contact with other land-based rescue services, ambulance for incidents, etc. But we do see that the use for these types of systems could be like remote infrastructure inspection after a storm, or any of the sort for municipalities, or anywhere time you need to drive far off to get some quick piece of information, or do something dangerous or dull, but we could use a fixed wing instead. We've seen an immense growth in the company from going to 2 to 4 people since last year. Here at the conference we have me and Filippa representing us, and back home we also have Björn Bringert and Fredrik Falkman. So this is the plane which you might recognize from last year. It's a Delta Wing, coming in at about 900 grams. The first one has gotten a new friend, so we now have 2 planes in the fleet. Our longest recorded flight is about 78 kilometers, which we did in about an hour and 24 minutes. More of like a long, slower mission, but we returned at 40% battery, so we're pretty, theoretically we can reach at about 130 kilometers before, going down, I suppose. It's made to sprint fast, so it has a top speed at about 30 meters per second to get out to the situation as fast as possible. And we fly over the mobile network to allow that kind of range. So essentially we've been operational for a few days now, since the two weeks back, where we had operational readiness, you can say, for real distress signals at sea. So this is what the offering looks like from the operations center point of view. So they send us a coordinate or a rough location that they get from the one calling in distress signal, and then we handle everything related to the drone and sending it out, flying it out there, and then we send them back a shareable link on email, so they just have one click to get authenticated access to the video feed and the telemetry stream, etc. So now over to the things we're working on. So now that we've seen the sort of drone operation from end to end, it's all about getting the best image we can from a fixed wing, which is quite a challenge. So at the moment we're using a custom-made servo gimbal, which weighs in at about 50 grams. It works fine, actually, but it becomes a bit of a bottleneck having to do this finicky construction with each new drone that we do. So we'd gladly, we have been out there testing other lightweight gimbals, such as those Randy was presenting, or similar to the one that Randy had on his drone earlier. Some of them, we've had quite a bit of issues during the testing phase, because they usually have hardware roll limits at about 30 to 45 degrees. And it's usually not that they just hit that roll limit and then when the plane levels out, they level out, but instead they start acting a bit weirdly. And we've had a few of them bricked for firmware updates, and they do these weird dances sometimes when occasionally when the roll limits are reached. So we're working, this is a screencast from our web-based GCS that we were using with the live video feed at the top and the map to the left where we just right-click and choose in the context menu if we want to fly or put a POI or like a point of interest or region of interest. And then to the bottom right we have the history view where we scrub back into the history or in the video feed if there's anything that caught our eye before. So to do this, well, we've tried to optimize this a lot, worked with different modes of the camera. So we're using GStreamer, so we've used that to, like the base mode is the 1080p at 30 FPS, but then we've also tried to dial down the frame rate to get high resolution imagery, which makes it much easier or much better images when you sort of pick them frame by frame and try to show them to someone. We've also done like uncompressed stills, so we use the full resolution of the camera. That requires that you change the camera settings, so you go dark for a while to do that, but you get really nice images, and we believe some sort of burst mode may be the thing to go for here. And then of course it's all about how the picture is used in the end, or the image is used in the end, so that's sort of guiding our process in all of this. We've also put a lot of work in remote landings because our pilots can be anywhere in Sweden, really. So in our interface, we've added support for right-click landings. So this might be important if, for example, the search and rescue helicopter enters the area where we've been taking images. We need to put the drone down fast. So here you can see the pilot laying out the mission, like an auto mission with a landing. And it gets like positioned into the wind automatically and some assists in that way. Remote landings makes us end up in undesirable places sometimes, but it usually leads to good learning experiences. So this was a good test for the waterproofness. So after this landing, we took it through our bespoke drying facility, and just 12 hours later, it was back in the launcher again, ready to go out. So that's been a good test. Now over to a very exciting development that we're doing. So essentially, when we talk to a lot of rescue services using drones today, mainly DJI drones within line of sight, they're usually they've started gravitating more towards lighter systems because one of their biggest expenses and time sinks is training both the pilots and the people watching the image. And of course regulations. So they don't necessarily want the biggest and best sensors because, for example, with an IR camera, you have to train both the person taking the image and the person analyzing it to what that does. And with a big organization, this becomes very cumbersome to maintain. So that sort of led us to this very highly integrated drone with a very specific payload, being just the camera, like the RGB IMX sensor currently. So this is a terrible illustration by me of the Swedish countryside, but here we also, on the regulation side, we plan on flying it really low, so we think we can achieve, with a minimal ground risk of a 249 grammer, we can fly really close to the ground, effectively separating us from other airspace as well, where other aircraft and drones might be. So this was initiated this spring with a master thesis student who did some great models that he flew. So the first one came in at about 300 grams and had a top speed of 25, which is also the limit of a 249 gram drone to go under the 80 joule limit that they also set. The estimated endurance was around 48 minutes, and which gave it a range of about 32 kilometers. Those are like preliminary numbers. Parallel to that, we took the RC test flight and think flight flick wing that they developed, and we bought that off the shelf and equipped it with the full stack from the 900-gram airplanes. So flew that with 4G and no gimbal, but 2 fixed IMX sensors. So one to the front and one facing inwards in the loiter. So we would get images instead of having to turn the gimbal. This is now at 283 grams, so we still have some work to do there. But it has the same top speed, and yeah, roughly we're aiming at 50 minutes of endurance. We'll try to shave off even more weight to make that longer. Some of the steps we're currently working on are it's a lightweight carrier board, so shaving off grams of the previous generation, so that we can get down to the limits that we need. We also want to do, obviously, our own frames with like injection molded or something like that. So that also, we aim to save a few grams there. Flying this close to the ground obviously involves terrain following. So we haven't, since we've been flying over the sea for a long time now, we haven't really been totally accustomed to the idea. But we have flown this 283-gram version with a LiDAR, which has worked really well during landings and such. So some type of software image stabilization we're looking at to ease the burden on the pilot especially, as well as to maybe extract like higher resolution, more focused imagery from the otherwise quite wide-angled camera. This is the current launcher. You see bits of here, which is like a long Pelican case, but for the small one, we don't need this much power at all, so it would be more like a carry-on bag is our end goal there. And we're also looking at a tail-sitter version, which would improve the landing procedure a lot, or make it a lot easier to land. And also, because we can't always, loitering around the place of interest will result in you having temporarily the image you want, and sometimes the sun is in your face, or there's obstacles in the way, etc. So with a tail sitter, you could potentially fly out and be still for a while, get the image you want, and send it onwards. Thank you so much, Kei Chan-man, Peter and Matt, and the rest of the 3DXR team. Thank you so much.
Hi. So, is there a reason why you aren't doing hand launches?
Sorry?
Is there a reason why you aren't doing hand launches, like throwing it up like a boomerang or something? Yeah, so, I mean, we have done like shake launches during testings and stuff, but we have, the launchers can be equipped with like a thing that, it's like a thing that opens locked cabinets. So we wind it up and we can remotely launch it like through our web interface using that. So the launchers are like to be equipped more with, or when they're placed out there, we're gonna electronically release them. So that's why. Right. Thank you very much. And this gives a lot more. I mean, the hand launches are a bit unreliable. So it's been using a catapult has been a game changer for us because it's great. It makes it the same every time.
Okay, thank you very much. Another round of applause, please.
Thank you.